When most people say styrofoam, they mean that lightweight white foam used in cups, takeout boxes, packaging, and coolers. But here's a fun reality check. Styrofoam is actually a brand name, originally associated with a specific kind of insulation foam. In everyday conversation, though, the word has become a nickname for polystyrene foam in general. So how does a hard plastic turn into a foam that feels like it's mostly air? Let's break it down step by step, because the process is a clever mix of chemistry, heat, pressure, and a little bit of engineering magic. Everything begins with a chemical called styrene. Styrene is made from petroleum-based materials and starts out as a liquid. To turn styrene into plastic, manufacturers use a reaction called polymerization. That's a science word that basically means small molecules linked together into long chains. When styrene molecules join into long chains, the result is polystyrene, a solid, rigid plastic used in many products, not just foam. Polystyrene is often shipped to factories as small pellets or beads, like tiny plastic grains ready for transformation. Styrene, aeropolymerization, aeropolystyrene, aeroplastic. Polystyrene by itself is dense and solid. To turn it into foam, manufacturers need to create tiny gas bubbles inside it. That's where the blowing agent comes in, commonly a hydrocarbon such as pentane. Think of the blowing agent as the air maker. It's mixed into the polystyrene beads so it becomes trapped inside them. Later, when heat is applied, the blowing agent turns into gas, causing each bead to expand like a microscopic balloon. Next comes pre-expansion. The beads go into a machine where steam heats them up. As the temperature rises, the blowing agent vaporizes and the beads puff up, often expanding many times their original size. If you want a mental picture, imagine popcorn, except each kernel becomes a tiny, lightweight sphere full of air pockets. Now you've got a batch of pre-expanded beads that are mostly air, but not ready to become a cup or a packaging block just yet. After pre-expansion, the beads are stored for a while in large containers. This resting period is often called aging or conditioning. During this time, a few things happen. The beads cool down, their size and density become more consistent, remaining blowing agent can slowly vent off, air moves into the beads, helping them become easier to mold. It might sound boring, but this stage helps ensure the final product comes out uniform and strong. Now for the main event, molding. The pre-expanded beads are poured into a mold shaped like the final product, a cup, a cooler wall, a packaging insert, or a big foam block. Then, steam is injected into the mold again. This second heating does two important things. It causes the beads to expand a little more, and it softens their surfaces so they fuse together. No glue is needed. The beads essentially weld to each other through heat and pressure, forming one solid foam piece. After that, the foam is cooled, removed from the mold, and it's ready to be trimmed, cut, or packaged. Steam plus pressure equals beads fuse equals one foam piece. Not all polystyrene foam is made the same way. Two common forms are EPS, or expanded polystyrene. This is the bead-based foam we've been describing, common in packaging, disposable food containers, and coolers. EPS is lightweight and made from expanded beads fused in a mold. B is XPS, or extruded polystyrene. XPS is made differently. Instead of expanding beads in a mold, the plastic is melted and mixed with a blowing agent, then pushed through equipment in a continuous extrusion process. XPS usually comes out as dense, uniform boards used for building insulation, especially where moisture resistance matters. Now, let's talk about the big downside. Polystyrene foam is lightweight, which makes it useful, but that same lightness also makes it easy to blow around, break into pieces, and persist in the environment. It doesn't biodegrade quickly, and when it breaks apart, it can become tiny plastic fragments that are hard to clean up. Recycling is possible, but it's challenging. Because foam is mostly air, it's bulky to transport.
That's why some places use densifiers, machines that compress foam into dense blocks that are easier to ship and recycle into new plastic products. Meanwhile, researchers and manufacturers are exploring alternatives such as molded fiber packaging, paper-based, starch-based foams, mycelium mushroom root packaging, and other lower-impact materials. The future likely includes less waste, better recycling systems, and smarter packaging choices. Here are a few quick facts to close it out. Polystyrene foam is mostly air, which explains why it's so light and buoyant. Those trapped air pockets make it a good insulator, which is why it keeps drinks hot or cold and helps insulate buildings. The same basic idea, trapping gas inside of plastic, shows up in many modern materials designed to save energy and reduce shipping weight. So the next time you see a foam cup or a packaging insert, you'll know what's behind it. Plastic beads, a blowing agent, steam, and a carefully controlled expansion process, turning rigid material into something light enough to float. If you want more how it's made stories from everyday life, drop a suggestion in the comments. And if you enjoyed this breakdown, like, subscribe, and I'll see you in the next episode of Explain History Things. History is hidden in everyday objects.